Right now, inside every cell of your body, a hidden process is waiting to activate. Scientists gave it a Nobel Prize. It could add years to your life. Most people will never trigger it, not because they can't, but because they don't know when it starts. You've heard about fasting, how it transforms health, burns fat, clears your mind, but here's what nobody tells you. The real magic doesn't happen the moment you stop eating. Your body follows a very specific timeline, a biological countdown. Miss that window and you're just hungry. Hit it right, and you unlock one of the most powerful anti-aging mechanisms science has discovered. The process is called autophagy. The word literally means self-eating. Sounds disturbing, doesn't it? But this isn't destruction. Your cells break down damaged parts. They recycle the pieces. They rebuild themselves stronger than before. It's molecular renovation happening inside you right now. So when does this actually begin? After 8 hours? 12 hours? 24? The answer surprised even the researchers who study it, and by the end, you'll know the exact moment your body flips the switch. More importantly, you'll know how to use that knowledge to live healthier and longer. But first, you need to understand what's happening inside your cells when autophagy activates. Because once you see this process, you'll never think about hunger the same way again. Every second you're alive, your cells produce waste. Damaged proteins pile up, mitochondria start to malfunction, toxic molecules accumulate. It's like living in a house where trash builds up in every room, year after year, never cleaned. Your body has a cleanup system for this. It's been inside you since birth. But here's the problem. That system only turns on under specific conditions. When you eat constantly, your cells stay in building mode. Breakfast, snacks, lunch, more snacks, dinner, dessert. They're too busy processing nutrients to clean up the mess. Growth never stops, repair never begins. This is where most people live their entire lives. Cells constantly fed, never cleaned, the damage quietly accumulating. Until one day, diseases appear that seem to come from nowhere. But they didn't come from nowhere. They came from decades of cells that couldn't clean themselves. Cancer, Alzheimer's, heart disease, inflammation that never stops, all linked to autophagy that never activates. So what exactly happens when autophagy finally turns on? Imagine your cells can finally stop building. They shift gears completely. Special structures form inside each cell. Scientists call them autophagosomes. Think of them as microscopic garbage trucks. These trucks identify damaged proteins first, then worn-out mitochondria, then cellular debris that's been sitting there for months or years. They wrap around these broken parts, seal them up tight, transport them to recycling centers called lysosomes. Inside the lysosomes, powerful enzymes break everything down, completely, into basic components. Amino acids, fatty acids, simple sugars. Nothing gets wasted. Your body takes what was damaged and dangerous, dismantles it completely, rebuilds it into something new and functional. It's molecular recycling at its absolute finest. But here's what makes this so powerful. Autophagy doesn't just remove random trash, it specifically targets the most dangerous parts first. The proteins that could trigger Alzheimer's, the mitochondria creating harmful free radicals, the cellular debris fueling inflammation and aging. If you're finding this fascinating, hit that like button. It helps more people discover how their body's repair system actually works. This is where timing becomes everything. The discovery didn't happen overnight. For decades, scientists knew cells had waste management systems, but they didn't understand the details. Therefore, the process remained a mystery until one researcher changed everything. In the 1990s, a Japanese scientist named Yoshinori Ohsumi started experimenting with yeast cells. What he did was brilliantly simple. He starved them of nutrients, then he watched under a microscope. What he saw was extraordinary. The cells didn't just sit there dying, they started consuming their own internal structures, but in a controlled, purposeful way. Therefore, these tiny organisms were performing surgery on themselves. Ohsumi spent years mapping this out, identifying every gene involved, every protein, every step of the process. His work was so groundbreaking that in 2016 he won the Nobel Prize. But here's the real shock. Humans have the exact same system, same genes, same proteins, Same cellular machinery. This process has been inside you your entire life, passed down through millions of years of evolution. Your ancestors survived famines because their cells could strategically eat themselves, breaking down what wasn't needed, preserving what was essential. That same survival mechanism still works today. The problem? Modern life almost never activates it. This is where the timeline becomes critical. So here's the direct answer you came for. Autophagy begins activating between 12 and 16 hours of fasting for most people, but it doesn't reach full power until 24 to 36 hours. Therefore, that's when real cellular repair happens. Now let me explain what's actually happening inside your body during this window, because understanding the process changes everything. The moment you stop eating, your body doesn't immediately think, "Time for autophagy." There's a very specific sequence that has to happen first. In the first 4 to 6 hours, nothing unusual happens. Your body runs on glucose from your last meal, insulin levels are elevated, your liver has plenty of glycogen stored, everything is normal. Around hour 6 to 8, things start shifting, blood sugar stabilizes, insulin begins dropping, your liver releases glycogen to maintain energy. You might feel completely fine, maybe even energized, but by hour 8 to 10, the first signals appear. Glycogen stores are getting lower, insulin has dropped significantly. Inside your cells, molecular sensors start to notice. These sensors are proteins called AMPK and mTOR. They act like energy detectors, constantly monitoring whether nutrients are abundant or scarce. When AMPK senses low energy, it activates. When mTOR senses low nutrients, it deactivates. This combination is critical. AMPK on, mTOR off. That's the biochemical signal. It tells your cells to shift from growth mode to maintenance mode. At around 10 to 12 hours, autophagy begins to whisper. It's not fully active yet, but the machinery is warming up. A few autophagosomes start forming. Some damaged proteins get tagged for removal. Most people never push past this point. They eat breakfast 8 or 10 hours after dinner, shutting down autophagy before it really begins. But those who continue fasting experience something remarkable. By hour 12 to 16, autophagy truly wakes up. Your liver's glycogen is depleted. Your body shifts fully to burning fat for energy. Your liver starts producing ketones, those powerful molecules that can fuel your brain when glucose runs low. This metabolic shift is the trigger. With insulin low, ketones rising, and energy coming from fat instead of sugar, your cells receive a clear message. Stop building. Start cleaning. Autophagosomes form more aggressively now. Damaged proteins get broken down faster. Old mitochondria are identified and marked for recycling. At 16 hours, many people practicing intermittent fasting stop and eat. That's not a bad strategy. At this point, you've activated meaningful autophagy. Your cells have had time to perform basic cleanup. But here's where it gets fascinating. If you push to 18 or 20 hours, the intensity increases. More autophagosomes, more recycling, more cellular renewal. The cleanup that started as maintenance becomes renovation. Your cells aren't just removing trash anymore, they're actively upgrading their internal machinery. Some people report feeling sharper at this stage, more mentally clear. That's not imagination. Ketones provide steadier energy to your brain than glucose does, and autophagy in your neurons starts clearing out protein clumps. The same clumps that contribute to cognitive decline. Your brain is literally cleaning itself while you fast. But wait until you hear what happens at 24 hours. 1 full day without food. For most people, this sounds extreme, but biologically speaking, this is where autophagy becomes a powerhouse. By now, your body is fully committed to fat metabolism. Ketone production is strong. Your cells have had enough time to complete deep, thorough cleaning cycles. At 24 hours, autophagy isn't just removing damaged proteins anymore, it's tackling entire structures. Mitochondria that have been producing energy inefficiently get dismantled and recycled. Think about it this way. Your mitochondria are like tiny engines inside every cell. Over time, these engines wear out. They start misfiring. producing less energy, creating more toxic waste. In a normal, constantly fed state, these broken engines just keep running, slowly poisoning your cells. But during autophagy, your cells can finally shut down the worst engines. Therefore, they break them apart and either rebuild them or create space for new ones. It's like replacing a failing car engine instead of just adding more oil and hoping it works. Your immune system experiences massive changes at 24 hours too. Studies show that fasting for a full day can trigger the breakdown of old immune cells. Then, when you eat again, your body produces fresh replacements. It's like updating your immune system, removing buggy code, installing a clean version. The brain benefits are equally impressive. Brain-derived neurotrophic factor increases significantly. BDNF. This protein is like fertilizer for neurons, helping them grow, form new connections, resist damage. Higher BDNF levels are linked to better memory, faster learning, protection against neurodegenerative diseases. Some researchers believe this is why fasting reduces Alzheimer's risk. When neurons regularly activate autophagy, they clear out beta-amyloid plaques and tau tangles, the toxic proteins that characterize Alzheimer's. Prevention happens at the cellular level, silently protecting your brain decades before symptoms would appear. But 24 hours isn't the maximum. If you continue to 36 hours, autophagy keeps intensifying. Before we go deeper, I want to know your take. If your body starts deep cellular repair after 24 hours, would you consider doing a one-day fast just to trigger this process? Comment 24 hours to reset if you'd try it, or not for me if that sounds too extreme. By 36 hours, something extraordinary happens. Growth hormone levels spike dramatically, sometimes increasing 5 times higher than normal. This hormone doesn't just build muscle, it protects existing tissue, while encouraging fat breakdown. Your body becomes remarkably efficient at preserving what matters: muscle, organs, bone, while aggressively targeting fat reserves. At this stage, autophagy reaches structures it couldn't access earlier. Protein aggregates that have been accumulating for years finally get dismantled. Cellular waste hiding in hard-to-reach places gets cleared out. Your cells are performing deep surgery on themselves, cutting away everything unnecessary, leaving only what's functional and strong. The mental effects can be striking here. Many people describe an almost euphoric clarity, a calm focus that feels different from normal consciousness. This isn't just psychological. Your brain is running on a completely different fuel system now, one that produces less oxidative stress and more stable energy. Evolutionarily, this makes perfect sense. When food was scarce, your ancestors needed sharp minds to hunt effectively. A foggy brain couldn't find food, so evolution designed fasting to enhance mental performance, not diminish it. That same ancient mechanism still works in your modern brain. Now here's the critical point. Beyond 36 hours, benefits start to plateau for most people, and the risks begin increasing. This is where autophagy crosses into potentially dangerous territory. There's a line between autophagy and starvation. Understanding that line is crucial. On the surface, they look similar. Both involve not eating, but biologically, they're completely different processes. Autophagy is controlled renewal. Your body carefully selects what to break down: damaged proteins, worn-out organelles, unnecessary cellular debris. It recycles these components intelligently. Muscle tissue stays protected. Essential functions continue smoothly. Starvation happens when fasting goes too long. The body exhausts its fat reserves. It starts breaking down healthy tissue, including muscle, just to keep vital organs running. Hormone levels crash. The immune system weakens. Mental function deteriorates. What was once a tool for health becomes a threat to survival. For most healthy people, the safe window is between 16 and 36 hours. This gives your cells enough time to complete meaningful cleanup, without pushing your body into crisis mode. Beyond 72 hours, you're entering territory where medical supervision becomes necessary. The key is understanding this. More fasting doesn't equal more benefits. Autophagy has a sweet spot, long enough to trigger deep cellular repair, short enough that your body still has plenty of resources. It's about strategic stress, not extreme deprivation. So here's the practical takeaway. You don't need to fast for days to get autophagy's benefits. Regular shorter fasts can be just as effective over time. Many people find success with time-restricted eating, compressing all meals into an 8-hour window each day. That means fasting for 16 hours daily, long enough to activate autophagy consistently. Without the challenge of skipping multiple meals, your cells get regular cleanup sessions, and you still enjoy satisfying meals. Others prefer the 5-to-2 approach, eating normally 5 days a week, doing 24-hour fasts twice weekly. This provides deeper autophagy sessions, while fitting easily into most lifestyles. You might fast from dinner one day to dinner the next, giving your body a full day of cellular repair. There's also the occasional 36-hour fast, done monthly or quarterly, for more intensive cellular renewal. Think of it like deep cleaning your house. Daily tidying keeps things manageable, but occasionally you need to move furniture and clean the places you normally can't reach. But fasting isn't the only autophagy trigger. Exercise activates similar pathways. When you do high-intensity workouts, you temporarily deplete glycogen. You create cellular stress. That triggers cleanup mechanisms. Your cells respond by removing damaged components, strengthening what remains. Certain compounds support autophagy too. Coffee, especially during a fast, contains molecules that activate AMPK, the same energy sensor that kicks off cellular cleanup. Green tea works similarly. Even compounds in foods like turmeric and berries have been shown to support autophagy. Dark chocolate too. Sleep might be the most underrated trigger. During deep sleep, especially in your brain, autophagy activates to clear out metabolic waste that builds up while you're awake. This is why poor sleep is linked to neurodegeneration. Your brain needs those nightly cleanup sessions to maintain long-term health. So the complete autophagy picture isn't just about fasting, it's about creating a lifestyle that gives your cells regular opportunities for repair. Fasting is the most direct trigger, but it works best combined with exercise, quality sleep, and strategic food choices. Now let's break down the complete timeline, because understanding the progression helps you maximize the benefits. Hours 0 to 8. Your body runs on recent food, insulin is elevated, cells are in growth mode. Autophagy is minimal, just basic background maintenance. Hours 8 to 12, glycogen starts depleting, insulin drops, AMPK begins activating, autophagy starts to whisper, preparing for the transition ahead. Hours 12 to 16, glycogen is mostly gone, fat becomes primary fuel, ketones begin appearing, autophagy wakes up, autophagosomes forming more frequently. This is where most intermittent fasters land. It's enough to trigger meaningful cellular cleanup. Hours 16 to 24. Autophagy intensifies, damaged proteins break down faster, mitochondria get recycled, inflammation markers drop, the brain starts running efficiently on ketones. This extended period allows deeper cellular repair. Hours 24 to 36. Peak autophagy, growth hormone spikes, immune cells regenerate, the deepest cellular structures undergo renovation. Your body is performing major maintenance now, not just routine upkeep. Beyond 36 hours, autophagy continues, but benefits plateau, risks increase. This territory requires careful consideration, often medical guidance. The timeline is clear. Autophagy begins around 12 hours, becomes meaningful at 16, reaches high efficiency at 24, peaks around 36. After that, you're pushing into territory where more doesn't necessarily mean better. If you're new to fasting, start with 12 to 14 hours. Work your way up. Let your body adapt gradually. The goal isn't to suffer through hunger, it's to train your metabolism, to efficiently switch between fed and fasted states. Stay hydrated during fasts. Water doesn't break a fast, neither does black coffee or plain tea. They can actually support the process. Electrolytes become important during longer fasts, especially sodium, potassium, magnesium. Listen to your body. If you feel dizzy, extremely fatigued, or unwell, break the fast. Autophagy is powerful, but it's not worth risking your immediate health. The benefits come from consistent practice over time, not from pushing through warning signals. And remember this, Autophagy is just one piece of the health puzzle. It works best combined with nutrient-dense foods during your eating windows, regular movement, quality sleep, stress management. Fasting triggers cellular cleanup. But what you do the rest of the time matters just as much. The science of autophagy reveals something profound about human biology. For millions of years, we evolved in environments where food wasn't constantly available. Our bodies developed this incredible repair system to take advantage of lean times, using scarcity as opportunity for renewal, instead of just barely surviving until the next meal. Modern life has disrupted that rhythm entirely. We eat from the moment we wake until we sleep, keeping ourselves in perpetual growth mode, never giving cells space to clean up the damage that accumulates from simply being alive. And the consequences show up as diseases of aging, metabolic dysfunction, neurodegeneration, cancer. By choosing to fast strategically, you're not depriving yourself, you're reconnecting with ancient biological wisdom, giving your cells permission to do what they've always been designed to do: repair, renew, optimize themselves from the inside out. The next time you feel hunger during a fast, remember what's really happening. Those sensations aren't weakness, they're signals that your body is switching gears, moving from consumption to creation, from building to repairing. Every hour you push past that initial discomfort, millions of cells throughout your body are working, making you healthier, stronger, more resilient. If you're fascinated by how fasting reshapes your body, you need to watch this next. What happens to your immune system during fasting? Science explained. It perfectly complements what you've learned here, showing how immune cells literally rebuild themselves while you fast. Trust me, it's one of the most underrated stories about fasting. After decades of research, most scientists agree on this. The sweet spot for meaningful autophagy lies between 16 and 36 hours of fasting. It's the window where your body transitions from fuel burning to deep repair. Long enough to activate the cleanup. Short enough to avoid harm. Short daily fasts like 16 to 8 keep your cells regularly tuned. Occasional 24-hour fasts enhance resilience, and for those medically fit and experienced, a 36-hour fast can deliver a full autophagic reboot. Beyond that, supervision becomes essential. The magic of this process isn't just in biology, it's in consistency. Autophagy isn't a one-time event, it's a rhythm. The more your body learns this rhythm, the more efficient it becomes at protecting and renewing itself. So next time you think about skipping a meal, remember this: you're not depriving your body, you're giving it a chance to heal itself from the inside out. If this video helped you understand how fasting activates your body's hidden repair system, hit the like button, subscribe for more Science Explained, and share. This with someone curious about fasting and longevity. You might just inspire them to start their own health experiment.